Hey there, I hope you're doing well. I'm Andrew, and today we're going to be taking a look at some of the changes to XR Toolkit for XR Toolkit 2.1 to 2.3. So what we'll be doing is I will first start off by showing you how to set up a basic project, and then I'll be going through the What's New section of XR Toolkit, and we'll go feature by feature, we'll talk about it a little bit, and then I'll show you how to set it up. So it'll be best if you already have some XR Toolkit knowledge. If this is your first video on XR Toolkit that you're watching, I'd recommend probably going back to my 2.0 video or just doing a generic search on YouTube. But with all that said, let's look at setting up a project. For the majority of this video, I will be using my own sort of sample project that I've put together with some sample scenes and examples, so you don't have to sit here and watch me kind of tool around in the engine to kind of get each little thing set up. To start, I would recommend using Unity 2020, the most recent LTS version. You can use later versions of Unity. However, it can be a bit difficult to use some of these earlier preview packages. And this is because of a change that was made to the package manager. You can edit the package manifest manually to put in particular versions of whatever plugin you would like, but you can just install 2020 and we don't have to go through that extra process. So if you want to do it that way, you're more than welcome to, but for this, I'm just going to stick to 2020 because it's the most straightforward way of getting the most recent version of XR Toolkit. If you're using 2021 or later, the version that we're going to be using will not show up in the package manager. So that's just a word of warning. But as you can see here, I have Unity Hub open in front of me. If you look up here at the top, we have 2020. I'm just going to be using the 3D template because I don't particularly like the VR template. It doesn't help me a whole lot and just puts a bunch of stuff in there that I'm not going to use. So I'll just name my project whatever I want to. And I'll just name it u.andrew project. That's fine. And I'm just going to hit create project. And once that's done, you'll see that we have this empty project open in front of us. The first thing that we're going to be doing, as always, is going to the package manager. So we'll go up to Window, Package Manager, and we'll just dock it right here in the middle of our screen. Next, we'll want to go from In Project. We'll want to go to the Unity registry. And before we even begin to search for a few things, we want to click on this gear icon. We'll go to our advanced project settings. We'll dock this one as well so you can see it a bit easier. And we want to enable the preview packages. This is something we had to do a while back and isn't particularly useful, I feel like, in the more recent versions of Unity, but we do need to click this to see the packages that we're going to be using. So we'll click I understand. Everything should be good. So let's close out of our project settings. Well, actually, we're going to come back to this. So let's go to our package manager. And we can just scroll down here because everything's pretty much going to start with X. So we'll go to XR Interaction Toolkit and we'll expand this and take a closer look at it. If you're using a different version of Unity, you'll probably only see like 2.2 or 2.1 or something like that. But if we click see all versions, we'll see that we also have this preview 2.3 version. So we'll select that and we'll just click install. And then we'll be asked to restart our editor, so we'll just hit yes. We'll go ahead. And now that that's done its thing, let's scroll back down. I don't remember. No, it doesn't. It doesn't install the XR plugin manager for us, so we'll install that as well. And before I forget, let's go back to the XR Toolkit so we can download some of the samples as well. We're going to need the starter assets as well as the tunneling vignette. So we'll import the starter assets and then the tunneling vignette. Alright, so I think we're done with the package manager, so we'll close out of this. Once it's done loading, we'll close that tab and we'll go to our project settings. So now we'll go down to our XR plugin manager. And I'm going to be using OpenXR, so I'm just going to be clicking that checkbox. And once that's done, it'll automatically put us to our project validation. So we can just come over to this Fix All button. We can click that and it's going to automatically apply some settings for us. And it may take a second, but once that's done, we'll need to just set up our interaction profile manually. So we'll hit edit on that. And I'm using an index controller, so I'm just going to go to the Valve index controller profile. And I'll click that. And now we're pretty much done for our actual project setup. So we can close out of our settings and let's just make sure this works. Let's go to our hierarchy. I'm going to right click in there. I'm going to go to XR and I'm going to go to XR Origin VR. And the nice thing about this is it gives us our little origin, gives us our input action manager, and it's already set up our input actions here. So it's going to activate them for us. I'm just going to set this to floor. You don't have to do that, but I just like to do it. And then we'll go over to our XR origin and look at our controllers. And let's just apply our actions really quick to make sure that this is all working correctly. So we'll do it the quick way, and we'll just go to our presets here. We'll click on our left controller preset for our left controller and our right preset for our right controller. And there we go. Let's go into our scene view here. Let's see, make sure that this is zeroed out, and I'm just going to create a plane so it's a little bit easier for us to sort of get our bearings. And that's it for that. I'm going to turn everything on and I'm going to play this in just a second. Alright, so lighthouses are on. Let's save the scene and let's hit play. An interesting thing enough, it didn't take out or convert our main camera here. So if you see that I'm getting this warning here down at the bottom, it's because there's another audio listener on this camera. So we'll just delete that. And we're looking around and that seems to all be tracking pretty well. I'm going to turn on one of my controllers to make sure we're going to get some values from there as well. So I'll move on down to Steam VR. We'll drag that in so we can see what's going on. It looks like our controller's tracking well. Let's check the inspector for our transform for it and see if that's working correctly. You usually have to also make sure that you're holding the headset sensor, if your headset has one, for it to track properly. So you can see that my right controller is actually working as expected. Alright, so that about does it for the sort of general project setup. I'm now going to switch over to my sort of sample project that I have a few examples already set up. So I'll be back in a second. Alright, and we're back. So this is going to be the sample project that I'm going to be working with. And this is the scene that I'm primarily going to be doing everything in. It's pretty straightforward, but we're still going to go through everything just so you can kind of see what I'm working with. As of right now, I have these two grab interactables. And these are just the ones, if you right click here in the hierarchy, you go to XR, they will be under grab interactable. Yes, it would be that one. I then have the Locomotion here, which is just our basic Locomotion system, a teleportation provider, and a continuous move provider that we'll be using for the Vignette in a little bit. But I primarily did this because I wanted to make sure I kind of had the rig all set up and ready to go, not only for direct interactors, but also for ray interactors. So if you see that once I expand these controllers here, you'll see that on the controller itself, it just has the XR controller. And then we have the sub-objects here for the direct interactor and the ray interactor. And I can do this because even though these interactors require a controller, they'll actually get a component in the parent. So we can actually kind of keep things separated and neat. So not everything's going to be slapped onto this one game object because it can get kind of confusing once you're working with multiple interactors. However, when I was doing this, I did realize that the attach point for the direct interactor didn't work particularly well. So that's why I have this extra empty game object here for an attach point that is just childed to the controller as well. And I've set that in the attach transform here. And then let's just collapse this really quick. And then we just have this simple interactable that we're going to be using for our poke example. And then we just have this canvas, which it's a pretty basic canvas. Just for it to work with XR Toolkit though, it has the track device graphic raycaster. And that's pretty much it. I do have a little sphere game object that gets created for my hand. And that's just a simple prefab, that's just a sphere. If you have your own project set up, then I imagine none of this is relevant to you, but it just kind of gives you an idea of how I'm going to be kind of quickly setting things up rather than you needing to watch me kind of troubleshoot a few things and probably adding a lot of time to this video. Okay, so let's close this folder. And we're first going to be looking at the 2.1 changes. So let's open up the documentation really quick. Okay, so here we are within the 2.1 documentation. Now, I don't exactly know how I want to kind of either do one part and come back to the documentation, or we'll just come to it once every major version change here. I think we'll just look at 2.1, we'll do all of these things, and then we'll move on to 2.2. So for 2.1, we have three major things we're going to be looking at. We have the dynamic attachment feature, we have intention filtering, and then we have the comfort mode vignette. All of these are incredibly memorable names, and I'm probably going to forget them at one point or another. Dynamic attachment feature is more or less the equivalent of the offset interactable that we've been creating for a number of years now manually because it wasn't included in XR Toolkit. You're not familiar with what that is. It's when you go to pick up a game object and it doesn't snap to a particular attach point on the hand. it maintains that sort of positional and rotational relationship, so it looks a little bit smoother. So we'll be looking at that first, and then we have intention filtering here, where this is sort of an interesting addition where, as of right now, interactors, if you are hovering over multiple interactables, it uses a simple distance check to find the nearest one for you to select. But now if we wanted to, we could create custom sort of what they call evaluators to try and figure out what interactable the player may be trying to select. And you can see here that there are 3 evaluators that are already sort of built into XR Toolkit. We have the last selected evaluator, the distance evaluator, which I just kind of talked about, and the angle evaluator, mostly used with head rotation to determine intent based on gaze. So in other words, if you're looking at something with the gaze interactor, you have to be fairly straight on looking at it and not have a shallow angle. But with all that said, I'm not exactly sure a use case that I would have for this. There is an example that they provided the documentation that we'll be looking at, where you can sort of base the sort of priority of an interactable based on what the tag is on it. So we'll look at that in a second. And then finally, we have the comfort mode vignette, which is just a additional sort of cone, just a vignette when you are smooth locomotion, and it sort of helps with motion sickness. And that's really easy to set up as well. All right, and I think that's enough of the sort of explanation for 2.1. Let's go back in Unity and let's set all this up. All right, so now that we're back in Unity, the first thing we'll be looking at is that dynamic attach point. And it's pretty simple. If we select one of these grab interactables, we'll go on down here and you'll see that we have use dynamic attach. You can see I already selected it. So this is what it'll look like here. And then once you click that, you'll have these options for how you want to customize it. I'm just going to leave this sort of standard as is so you can just see how it works. So we'll hit play and we'll test this out. And as you can see here, when I'm grabbing the different sides of the white cube, the cube does sort of slide to sort of connect the collider with that sort of attach point on my interactor, but it maintains that sort of rotational relationship. If I go to then grab the pink cube and I rotate my hand and then grab it, you'll notice that the cube sort of quickly rotates into the position to match the orientation of the attach point. That's it for the dynamic attach transform. Now let's look at the intention filtering, where this can be a little bit difficult to set up. Because when I first started trying to get it to work, I thought you needed to put it on an interactable, but actually we want to put it on an interactor. So let's just add it to my right-handed direct interactor here. So let's add a component that we'll just call, or that is called the XR target filter. And you can see here by default, it uses the XR distance evaluator. So if we select that, you'll see that we have these options for sort of controlling the weight of this particular evaluator. So I'm going to remove that and I'm going to add this custom one that I got from the documentation, which is exclude by tag evaluator. So it'll weight these different interactables based on whatever it's tagged. So if we want a particular tag to exclude, we'll just name it something imaginative like exclude. And then we'll go with the white one cube here again, and we'll just add a tag here. We'll add a tag, and I'll just call this exclude as well. And we'll make sure that we actually tag this game object to exclude. And at this point, this interactable is all set up, but we need to actually manually set the interactor filter. So you'll now see that we have this collapsible area here. If we expand it, you can see the starting target filter. So we can actually drag this up, and then there we go. And before we actually test this, let's look at the script a little bit closer so we can see what kind of behavior we can expect. Alright, so now that we're in Visual Studio, we can see that this exclude by tag evaluator actually inherits from the XR target evaluator. And we get this function called calculate normalized score that we can override this sort of base function that's in the XR target evaluator. And what this does is it'll give us an interactor, an interactable, and it's going to return a float based on whatever comparison that we're going to do here. So if we've tagged this interactable with exclude, it's going to get a value of 0. If it's untagged or any other tag, it's going to get a value of 1. And whatever the higher the value is, the more it's going to be prioritized. So let's go back into Unity and look at this scene to see how this is actually kind of applied. So if we go back to this pink cube, since it's untagged, it's going to have a value of 1. And because this white cube actually has the exclude tag, it's going to have a value of 0. So pretty much any time that we're going to try and select these two interactables, if they're close enough to each other, are being hovered at the same time, it should primarily prioritize the pink one the majority of the time. So let's actually just move this over a little bit so it's closer to the white cube, and let's hit play to test this out. So as you can see, even though my interactor is clearly going to be hovering over both these interactables, it's always going to be prioritizing the pink cube because it doesn't have that exclude tag, even though if it was based on the distance, it would most likely be grabbing the white one. Alright, I think that's enough for intention filtering. Let's actually look at using the vignette now. So let's collapse these two things, and we'll go to our samples folder. We'll collapse our little scripts here, and actually our starter assets as well. And we'll go to this tunneling vignette. And this comprises of a custom shader and a material and this little prefab that it's given us. It also works off this little hemispherical mesh here. I thought we could look at it a little bit more closely, but I don't think it's gonna show up. Oh well, all we actually have to do to implement this is we just want to drag the prefab to our main camera and child it. And we'll actually be able to see the mesh here. So let's try and double click on that. And we can go over here to our parameters here. If we want to change any of the settings for the size of the opening, the color of it, how the animation works. And you can see that if you come down to preview and editor, and you go no effect and you go default parameters, and it'll actually show what this will look like when it's being activated. So we can adjust the sort of feathering effect, which is the edge of how sharp it is, as well as the opening itself. But we're just going to keep it at the default for the time being. So let's collapse our parameters. And for this to work, we need to give it some sort of locomotion provider because it needs to most likely work off these start and end locomotion events. So let's click the plus button here. I'll go to my locomotion game object. You just go to whichever game object happens to have your continuous locomotion on it. And we'll just drag that into the locomotion provider. And that's technically all set up. I'm actually going to go to my locomotion game object to see what I have set up here. I currently have the left hand set up. I'll just slot in my locomotion system really quick, just so it doesn't have to get it at runtime, and we'll hit play. And I just realized I put in the wrong locomotion provider. I put in teleportation. Let's go back here. And it's the continuous move provider. So this is where it can get a little bit interesting. Oh, I think this is, I didn't realize this, but there's actually this little drop down. So we can actually select our action-based continuous. So there we go. Now it's the proper provider. Let's try that again. So as you can see, anytime I move, it's automatically going to be adding that tunneling vignette. And that's actually a pretty handy addition because that's kind of one of those really annoying things you need to make from time to time. But that's it for the changes in 2.1. Let's actually take a quick break and we'll come back and we'll take a look at 2.2. See you then. Alright, welcome back. Now we're going to be taking a look at the documentation for what's new in version 2.2. You can see that we have three things roughly again. We have multi-grab support, we have some starter prefabs, and we have some locomotion improvements. So if we scroll down a little bit here, multi-grab support is more or less what it sounds like. Instead of before when we were trying to create interactables that we could use with two hands, we would use multiple interactables that were then childed to other interactables, and it was just a gigantic mess. And it was usually something I tried to avoid doing or making videos about because it just wasn't a particularly elegant process. But now that XR Toolkit has now added multi-grab support, it also has added what is known as grab transformers. And this is how we can customize behavior based on if we're grabbing an object with one hand or two hand, and how it can position and rotate itself based on the position of our hands. And there's some built-in transformers that come with XR Toolkit that we'll be looking at, but we also have the possibility of creating our own. We won't be doing that in this video, but that may be something we can look at in the future. We then have our starter prefabs, which we've already kind of been working with, but we're specifically going to be looking at a sample scene that includes some stuff that's already set up by XR Toolkit. We then have these locomotion improvements, where I'm not going to be looking at the additions made to changing the rotation of when you teleport, but we will be looking at setting up the grab move provider, where that will enable us to move by reaching out and grabbing the air and being able to pull ourselves. And we can do that with either one hand or two hands, and those kind of have different but connected ways of setting them up. It probably sounds a bit vague, but you'll see in a little bit. So let's go back in Unity so we can start trying a few of these things out. Alright, and the first thing that we're going to be taking a look at is the multi-grab support. So let's click on one of our interactables here, and I'm just going to hit play just so you can see something that XR Toolkit is doing for us that you may not realize. And what happens here is that once the scene sort of initializes, XR Toolkit, if a interactable doesn't have a grab transformer, it'll add this XR general grab transformer for us. And this is where it'll actually enable us to have different settings depending upon how we want this object to behave when we grab it. So if we wanted to be able to select this interactable with multiple hands and then be able to pull our hands away from one another and be able to scale it, we could set that up here. But let's actually try another example, where we also have this XR dual grab free transformer, where we can customize where the object is positioned when it's being grabbed by two hands. So instead of having the position just being at the first interactor that selects it, we can actually set it to the average, so it'll be in between both of our hands. And the rotation will be the average of both of our hands being rotated. But for this to work properly, we also want to go to our select mode and we'll hit multiple. And let's make a mental note that this is going to be our pink cube, and let's hit play. And as you can see, we can grab this one interactable and we can grab it with both of our hands, and then we can kind of rotate it around as if we had handles on it. But with the scene still running here, if we actually scroll down, you'll see that XR Toolkit has still added this XR general grab transformer. And that's because if we go to this grab transformers configuration, we'll see that we'll have different transformers based on if the interactable has a single grab or a multi-grab. So as you can imagine, if you had a rifle that you could either shoot with one hand or two hands, a single hand, it would most likely grab it by the grip and it would sort of rotate and behave as expected. But as soon as you grab it with another hand, then obviously we would probably want some different functionality for how it would be aimed. But let's stop play mode and see what happens here. You'll notice that now these aren't set up at all. So what we can actually do is if we wanted to, we can set these up beforehand. So if we expand these two little sections here, if we wanted to say, oh, this is what I want for my multi-grab transformer, and then we wanted to add the general grab transformer, and we could put that on our single grab, we could then edit the settings here beforehand. But if you're okay with these basic settings, you don't have to do this. But if you want to play around with it, feel free to do this now. Okay, now I think that about does it for the multi-grab support. Let's look at that sample asset that I mentioned earlier. Let's go to our samples here. We'll expand all of this nonsense. We'll go to starter assets and we'll go to this demo scene. And you'll see that it has a lot of examples for our sort of basic grab interactable types. You've probably seen this before where it goes from the kinematic, the instantaneous, and the velocity. We also have some examples for gaze interactables and also some UI stuff. And we also have a teleport area and some teleport points here. And if we come over here to the right, it also utilizes this complete XR origin setup. So we more or less have the opportunity to use any type of interactable that's more or less included within XR Toolkit. So this is a pretty good scene if you need to use it as a quick demo to show someone at your job or whatever the capabilities of XR Toolkit. Using some of this stuff in an actual project, I don't know how beneficial that is, because there are some custom scripts here. I haven't really experimented with all of them. There may be one or two that are pretty useful, but I don't know how useful this is for most people, honestly. Because I'm looking for a particular script, but I can't seem to find it. Let's check the hands really quick. Oh, okay, here we go. It also has these action-based controller managers, which may be pretty useful because it will switch between all of the different interactors for you. We do have Interactor Groups now, so I don't know how useful all of this is, so you may need to take some time and experiment with this on your own. But now let's go back into our main scene so we can set up our grab locomotion. And let's go to our locomotion game object here. And you'll see that normally we have these different providers on this separate object. But what's interesting about the sort of grab locomotion is that we added here, you'll see that it also requires a controller transform. So it kind of hints off the idea that this may be better suited to put on the controller rather than this locomotion game object. If you put it on an object like this, you'll most likely need to set this controller transform manually. But if you have it on the controller, it'll get this transform automatically and you won't have to worry about anything. And just to see that in action, let's just hit play and see what it does. Just to make sure. Yeah, so you'll notice since we didn't set that transform, it's just grabbing the transform of the game object that it's on. And we'll see that does it have a little tooltip here that says the controller transform that will drive grab movement with its local position. So obviously we want the transform of the controller to be here, so we'll actually get some movement. And since controllers have enough stuff on it, I'm just going to leave it on this Locomotion object and just manually slot in the controller transform. And I'm just going to use my right controller for this. And when you're doing this, you also want to make sure for this grab move action that you're going to be using whatever input is properly related to the controller. So we'll use a reference here. And we have a new action that we actually use for this, and it's the grab move, I believe. We'll use the right hand. Just make sure those two are right. And let's actually, you know what, let's take a closer look at this to see, double check what input this is using. So if we expand this, we can see that it's the grip press. So anytime we're going to grip the controller, we're going to pull ourselves forward and it should move our camera rig. So let's exit out of our input and let's test that now. Okay, cool. This looks like it's working as expected. But I imagine you'll probably want this for both of your controllers. So what we would actually need to do is set up another one of these grab move providers. And I forgot to manually set the Locomotion for the first one, so let's do that again. We will go to our left controller and we'll use a reference for our move grab, and it will be our left hand. Cool. Now, this should work as expected. Obviously, we're getting a lot of components on this, so let's collapse a few of these things. And we set these up separately because if we want to use two-handed grab move, which will give us some more functionality for scaling and things like that, you'll see that it requires a left grab move provider and a right grab move provider. So we would then just set our right hand here and our left hand here. So this will also let us rotate ourselves as well as scale if we want to. So let's try this now. And everything, and it looks like it's working as expected. However, I'm not sure if the rotation is working since it seems like it pivots from the middle of the camera rig rather than the location of where the player is standing. But let's try a different setting really quick. Let's disable rotation and let's try require two hands for translation. And that's, I have actually never tried that before. It's kind of interesting. It's almost like a rowing action or something like that. All right, cool. So that about does it for 2.2. Let's take another break. Let's make some coffee and I'll see you back here in a little bit. All right, so welcome back. Now we're looking at the what's new in version 2.3 section, where we actually have quite a few things we're going to be going over with a few little extras as well. And the first thing that we're going to be looking at is the poke interactor, which may seem just kind of like this random interactor that lets you put your hand through objects and will sort of measure how far your hand is within that game object, and you can use it for things like buttons, but you can also actually use it to click on pieces of canvas. So you can have canvas buttons and drop downs, and you can use the poke interactor to actually touch them without needing to add colliders to them. So the poke interactor is actually like really useful, and I imagine it may be glazed over by a lot of people. So we're going to be looking at this a little bit closely. And then we'll be looking at the gaze interactor here, where we can either attach this to our controllers, but as you can imagine, it makes a little bit more sense to use on your head. So we'll talk a little bit about that and how we can set that up. It's a little bit interesting because it inherits from the ray interactor, so it kind of requires a controller in a sense, but not really. You'll see more when we get an engine. But if we scroll down here, you'll see that we have interaction groups, where this is a really useful feature for when we're using those direct, poke, and ray interactors, but we don't want to be selecting all of these different game objects with all of these different interactors at the same time. But if we look at the sort of explanation here, it says this behavior allows a developer to group interactors together, allowing only a single interactor per group to interact at a time. And the big thing to know here is interactors are mediated based on which one is highest in the list, meaning it has the highest priority, or if an interactor is currently hovering or selecting. So if you're trying to teleport or poke something, you're not accidentally going to be doing these other interactions with these other interactables that are on your hand. So this is really useful. And then finally, we have the interaction affordance system. And admittedly, this is a pretty intense system. I don't even know if I'll fully explain it well enough, but so we'll just read the definition here. And it says, the affordance system allows a developer to define specific type of interaction feedback, parentheses, affordance, for an interactable that may take many forms, including visual changes such as material color or size, audio clips, or even trigger haptic pulses. So in other words, this is kind of like a tweening system that will automatically hook into events that can happen from interactables. So if you wanted to play a sound or change color when you hover it or you select it, this system basically takes care of that for you. And I've only really scratched the surface of this, so we're probably going to stumble through this section a little bit. So let's go back into Unity and try some of these things out. Alright, so now that we're back in Unity, I actually forgot to add a poke interactor to my rig, so I'm going to do that now. It's actually really simple. I'm just going to use my right controller here. I'm going to disable the direct interactor for the time being. We'll right click. We'll see if it's in the XR section here. We have array, direct, gaze. There is not a poke interactor. That's fine. So we'll create a empty game object that we'll just call poke. We'll add a component and we'll just do poke interactor here. And believe it or not, we don't need any colliders or anything like that. So as soon as we have it on our controller, it's pretty much ready to go. And the interesting thing about the poke interactor is that it still fires hover events, but it can also do selections as well. And that's if you push halfway through or to the center of like whatever collider you're poking through. So I have this really big cube here that is just a simple interactable. So I can't grab it, but it does have all of the events that we can expect. But for us to see those events a little bit easier, I have a component that I think I just called it XR debug or something like that. Interaction event debugger. So this will just print some little messages based on the hovering and selection and all that stuff. But what we can also do is that if we wanted a little bit of control over our poke interactions, we also have the poke filter that we can put on interactable objects. So we can control the direction of how it's going to be poked. So based on this little debug line here, we can only sort of poke in within 45 degrees of it, and we kind of need to poke more or less past this point here for it to actually work as a selection. So let's hit play and we'll try that now. So as you can see down on the console, we're getting both these hover entered and select entered and exited events. I think let's try and go over to our scene view so you can see this a little easier. And hopefully this still tracks properly. Let's also disable these 3D gizmos. There we go. So now you can see how that's working a little bit easier. Let's now go back to our game view and we'll see if this is actually working with our canvas button. And as you can see, we're getting the transition, so we're actually being able to click this button without any actual functionality or collisions. So let's come out of play mode so I can explain that a little bit more. And we can do that if we go to the poke interactor here, and let's take a closer look at the script. And as you can see here, you can see that we have this interface here that's called IUI Interactor. And this is an interface that allows this interactor to interface with our canvas elements. So there's even the possibility of creating your own custom interactors and adding this interface onto it if you want your interactor to be able to interact with canvas buttons, drop downs, that kind of stuff. And that's enough of that. Let's go back into Unity. So let's collapse all of this because this just looks like an absolute mess. And let's go to our headset now so we can talk about a gaze interactor. So when we look at things, we can hover and select it. And I'm not sure how far along this implementation is because I think there's a few extra checkboxes you need to click to make this work. So I don't know how correct this is, but it works. We have our camera selected. Let's go to add component and we'll do our XR gaze interactor. What's interesting, kind of how I mentioned previously, is that this component requires the game object to have an XR controller component. And this is because since it inherits from the ray interactor, we won't open up the script, but we'll select it really quick just so you can see it. You can see right here, it inherits from the XR ray interactor, and the XR ray interactor inherits from, let's see if we can find it here, inherits from the base controller interactor. So it needs a controller to operate for its input. So this warning here may be a little deceiving. So I'm not exactly sure. I think I'm using this right, but don't quote me on any of this. But we'll just get it working in the meantime. And to get this to work, we don't need a whole lot, but what we do need to do is scroll down here, and we'll look at this hover to select. And this will enable us to select objects that we've hovered on for a particular amount of time. So we'll enable this, and it'll have a default time of 0.5. We also want to, any interactables we want to be able to gaze at for interactions, we need to set something up on those as well. So let's click on our pink cube here. Or maybe we should do one that isn't a grab interactable, because that may be a little weird. So let's go to our bigger cube here, where you'll see that we have this extra collapsible area for our gaze configuration, where we want to allow gaze interaction, and we can allow select and gaze assistance. And this is if we have a snap volume, which I think we'll try and talk about in a little bit. But let's just try allow gaze select. And we have our interaction event debugger here, so we can make sure that our gaze is actually working. So let's hit play and we'll see if this works. And as you can see, we're getting our hover entered and exit events, but we're not getting our select events. So there's probably a checkbox I missed. I think I know what it is. If we scroll back up here, we may actually see it. We'll see that we have our select entered actually here, but what we also need to do is auto deselect and click that as well. So we can actually select it and then deselect it. Kind of like I mentioned before, this is a little weird, so I don't know if this is the full implementation of it. So let's try that again. Alright, so now as you can see, we're getting our hover entered and exit, but we're also getting our select entered and exit as well, based on these times down here for 0.5 and our 3 seconds. So I think that's working more or less as expected. So let's stop playing, and now we're going to be looking at our interaction group. So let's clear our console here. And let's select our right controller, and let's add an interaction group. And if you remember, like I said, it's going to take the priority of whichever one is highest up in the list. So if we come in here, we'll actually add, we won't make it too complicated. We'll just add our direct and our ray interactor here as an example, and we'll also enable them. So we enable those. We'll add our direct interactor first because I want that to have priority, and then I'll add the ray. And usually I would probably just have the ray disabled by default, but what we're going to try and do here is we're going to select something with our direct interactor and the ray should disappear, just to kind of show that once one of the other interactors has kind of taken control, it's going to disable the other ones. So let's hit play. And all of my gaze interactions are firing off, so let's clear those. So as you can see, even when the direct interactor is just hovering over an interactable, it's going to automatically disable that ray interactor. So I can imagine with a little bit more setup, you can get these two interactors working like they would in a traditional VR game. I know up until recently, this has been a pretty difficult thing to do for whatever reason. Alright, so let's exit out of play mode now. And we have two more things that we're going to be looking at. The first thing of those two things is going to be the Affordance System. So let's go to one of our interactables. These things are getting pretty filled up with things now. And let's create a sub object here that we're just going to call Affordance. And we'll add a new component that we're just going to call, or we're adding a component called, that's called the color material property affordance. And what this is going to enable us to do is change the color of this object via its material based on some events. And you'll see that it's also added this material property block helper, which we'll talk about more in a second. But we also need a state provider, I believe. It's the XR Interactor Affordance State Provider. And we'll just drag this up to the top because it's kind of the most important one. So what this is going to do is it's going to connect whatever interactable we put into it to some basic events so that we can use some values from somewhere that we'll talk about more in a little bit to change the color of the cube. I know that sounded like a lot, but don't worry, we'll break it down as we kind of go along. So we'll start at the top and you'll see that we need an interactable source. Obviously, we've childed it to this particular interactable. I believe it would get it automatically, but let's set it manually. And then we'll also need a renderer so we can change its material. So we'll drag in our cube again. We also need a state provider that's going to be kind of hooking up this interactable's events to the functionality for changing its color. We can just drag this in. But then we finally have this affordance themed datum. I don't even know if I'm saying that word correctly, but it's basically a scriptable object that's going to hold some values for what we want this object to look like when we hover it or when we select it. So we want to go into our assets window, we right click create XR, You'll actually see we'll have this affordance theme as well. And this is the one we'll actually be using, but within XR, we also have these value datums for more sort of just general information that we want to share between game objects. That's not related to this though, so don't worry about it. Let's go to our affordance theme, and we want to have a color affordance theme since that's what we're going to be changing. So we'll click that. And if we want to kind of add some comments to sort of remind us what this was for, we would put them here. But for our value, this is where we have all of these different values that we can use for each of these events or different states, whether it's disabled or it's idle, hovered, selected, or activated. And these can be a little confusing because they kind of differ based on the different events that are being used. So let's hook this up and we'll come back to it. We'll click on our affordance game object and we'll drag our affordance theme into it. And one other thing you'll notice is that we have this color property name here. And I believe base color is the default for URP, but I'm using the standard render pipeline currently. So if I actually go to the material that's being used for this game object, and we'll look at the code for it really quick, you'll see that it doesn't use base color for its property. It uses underscore color. So if you're going to be using this stuff with the standard render pipeline, you'll need to change the default value here from base color to just underscore color, so it knows what property to change. So we'll change that to just color. Cool. Now let's go back to the color affordance theme, where this is going to have different color values for the state we want it to start in and the state we want it to end in. You'll notice that both the start and the end value for this idle state is black. So let's drag our game view over here and let's just hit play and we'll just see what happens here. Well, it turned black. Who would have guessed? And I imagine that's not what you probably want by default. So let's stop playing. We'll go back to our affordance object, and we have this little checkbox to say replace idle state value with initial state. So this will make sure that it stays white despite what our theme is going to afford us. So we actually don't need to worry about that now, but let's go to our hovered now to see, when we start hovering this object, what color do we want it to change to? And this is where it can get a bit confusing because you're like, well, if it hovers, what color does it use at the start value? Does it use the end value? For hovered, it uses start. If it's just a simple binary, it's hovered or it isn't. I think maybe for different interactables, this maybe behaves differently, but I haven't experimented enough with it to know for sure. When we hover a game object, for this example, we'll just make it hover to red. So we'll set that and let's just try it out really quick. And as you can see, when we hover it, it changes from our white color to the red color that we've set up within our theme here. And this is just really scratching the surface. You can also do this, like I said, for audio as well. We won't be doing that here because I think this video has probably gone on long enough, but you could still come in here and say, if we just type in affordance receiver, what other things we would want to do based on our events. So if we wanted to click on audio, we would now have this audio source. We would then provide it with its own theme. And we could also probably use the same provider as well, if we needed to. But I think it may be easier to use a different state provider for each different receiver, because if you want to sort of customize which events react to which affordance receivers, you would control that here. So if you want to only have the color change when it's hovered and maybe have sound only on select, you would probably need some different providers for them. And like I said, I think I'm probably just scratching the surface of this system, so there may be a video particularly dedicated to this in the future. All right, I think I'm running out of gas here. Let's look at one more thing. And that's just going to be the lazy follow, which is something we actually haven't discussed with something that we didn't discuss previously. And I think we can just use this cube as an example. So let's collapse this. We'll collapse this grab transformer and we'll add a component just called lazy follow. And what this is going to do is this is going to follow, or something that we can use to follow the camera. So if you have a piece of UI that you want in the center of the screen, this functionality will basically do that for you. So we want it to follow the head transform or the camera. So we'll just drop in that. We have an offset here, so it's going to sit 1 meter away in depth away from the player's head. And then we can also control some of the finer details here. So let's actually, this is probably going to break my game view because it always does. There it goes. We'll clear this, we'll re-expand this so we can look at it. We'll save our scene and let's hit play so you can see this in action. And as you can see, as I look around, the cube is following the center of my vision. It would probably look a little bit better if we didn't have a rigid body. So let's try and put this on just a regular cube here. And we'll shrink it down as well. We'll move the collider just to make it a little bit easier. There we go. And let's also remove it from our other one so we're not being chased by 2 cubes. Okay, cool. Let's just raise this up so it's not gonna bother anything. And as you can see, we're now getting a much smoother result. Yeah, so don't put rigid bodies on your lazy follow objects. And I think that about does it for this quick look on all these new features that have been added to XR Toolkit. And feel free to leave a comment below if you'd like to see a video exploring one of these features in more depth. I imagine you probably have a lot of questions and there's still a lot of stuff to explore. But I think that's it for me. Thank you for watching this far in the video, and I'll see you in the next one.